So in the previous video we had implemented RAI using pointers. Okay, so back then I told you that the standard way of RAI implementation can be done even without using an pointer, or you could say a unique pointer. Okay, so for this purpose I have created 3 different programs. Okay, so I've already written the code. Okay, so I'm just going through the code. Okay, so first we will see the non-RAI versions like yesterday we had seen, and so that we can appreciate the usage of RAI. Okay, so here what we have done is, first one is the shallow copy version. Okay, in the assignment issue also, the second file that you see, you will have the same issue which was due to shallow copying of the objects. So going back to the literature. Okay, so in C++ there are 2 types of like assignments, or you could say copying of objects. So whenever you are creating class and you write a copy constructor, okay, in that copy constructor you can do copying with 2 ways. Okay, so either you could choose a shallow copy, which is in this case we have done a shallow copy. So here if you see the constructor, we have dynamically created a data of or you can say an array of integers. Okay, and in the destructor we have cleared that data, freed that data, but here we have also implemented a copy constructor. So what copy constructor does is, as I said earlier, it will copy your data, so it will make a copy. So here what happens is, when you use a shallow copy, you are referencing the same object. Okay, so the reference is not replicated, so essentially you have 2 variables pointing to the same location. Okay, so this will lead to a problem called as double deletion, which is caused by shared ownership. Okay, so that is the reason why we are using unique pointers in RAI in recent times. So even without using this thing, so few steps that we have to implement is that if you are implementing a copy constructor or an assignment operator, overloading an assignment operator, then you need to make sure that they are deep copies. Okay, they perform deep copies. So here I will show you what happens with a shallow copy thing. So this will cause a double deletion. So we'll run this program first. I've already compiled all these programs. Okay, so just show you what happens. Just taking this thing over here. Okay, see here, free, double free detected. Okay, so this will cause a core dump. Okay, it's basically a crash. So what happens is, like as I said earlier, here in the main code what we have done is, we have created object 1, and again I have created object 2, and here I have used assignment for that thing. So this is a copy constructor. Okay, so it will assign this thing, and when the object goes out of scope, they both try to delete the same data. Okay, so as I said earlier, they point to the same this thing location, so they will try to delete the same data. So the first one, whichever gets the lock, okay, so that will delete it. So that has successfully left. Now there is a location that is already marked as deleted, and when the second object that was remaining to be destroyed tries to free that location, okay, again this delete will be called, then you will get a core dump. Okay, so this was issue with the copy constructor. So similar ways we have issue with the assignment operator when it is overloaded. So I have written both the cases in different programs. So similarly here also, if you see here, I have simply used assignment operator. Here also you will see I have used assignment operator, like is equals to you are using, and this is the source and this is the destination. Okay, so here it is copied. Okay, and here also you will have a different set of issue. Okay, so this will be a memory leak essentially. So we'll run this as well. See, so as always what happens here is, when object 1 is created, object 2 is created. So here how different it is. So like here I've just assigned it directly over here itself. So like that is a copy constructor, and here I have created two objects, and after creation I am assigning the values. Okay, so both are already constructed objects. Okay, so that is why when I am using a assignment operator, what it does is it copies. So now they are first, initially they were two different locations. Okay, so one location is already leaked. Okay, so this, whatever this thing was pointing first, so like object 1, that is now a leaked object. Okay, so that is lost reference. Okay, and the one that they are pointed to now, like object 2 and object 1 are pointing to the same object. Okay, and now again there will be a race condition. Whoever digits, or you could say freeze the space first, will cause a problem for the second person who will try to release the resources again. Okay, so this is also what you call a chaotic state. Okay, so for that reason finally we have a fully working RAI version. Okay, so in this what we have done is similar two steps are there. Okay, the first steps, you could say the constructor and destructor are same over here. The only difference is the copy constructed. Here we are using a function called as std copy. Okay, so std copy is a feature that is useful to copy in a deep copy manner. So as I said earlier, in deep copy you are getting two distinct memory locations where data is copied. Okay, so there are no shared reference or anything of sort. Okay, so here std copy other dot data, so other is the reference value over here, and here if you see what it has done is here we have assigned new over here, so new data is already there. Okay, so here when a copy is made for the other this thing data, it is reconstructed copy. Okay, so copy constructor is slightly different from this thing. Okay, so here we have used std copy. Okay, so here we have not used any std copy. See here, so this is a non-RAI version, and here we have copy constructed it, and again with the assignment operator. Okay, so get rid of the syntactic sugar. Okay, so this is checking this, the pointer and stuff, so that is not important for now. Okay, so here from here you can see it is first deleting the existing data. Okay, so whatever the original object had, that should be deleted. Okay, so a new object is to be created. Here also the same thing is done. So like new object is created. Okay, and then that data is passed. Okay, so this, if you see the, I've hovered it over, so this is the first location, last location, and the resultant where it is to be copied. Okay, so here before you copy anything, here we have a constructor, or you could say this thing that creates a new 100 locations, or you could say reallocates the location, and then the copy is done. So these are two distinct objects. Similarly here also we explicitly delete the original fields or data that we have, then we create things again, and then we copy. Okay, so that is how deep copy is done. Okay, so I hope you got the difference between a shallow copy and a deep copy. So that was one aspect, and now in this thing, the modern C++, you would say there's a concept called move constructor as well. Okay, so this is you could say something that is relatively only related to the modern C++. This is something you would not find in the older C++ versions. Okay, so move constructor basically moves the object. Okay, so ideally whenever you're moving the object, the original object should be either deleted or should be pointing to a null. So this is what it takes care of. So here the other dot data, the previously from where, so what we have done is we have copy constructed over here, you can see the other data, and this we have turned into a null pointer. Okay, so release ownership, so this will be release, and Also we have implemented this move assignment operator here. So if you see carefully these two functions, the copy constructor and this thing, they look similar. The only difference you will have to see here is the ampersands. Okay, so for the copy constructor you will find a single ampersand, and here you will find two ampersands. So the whole move semantics and copy semantics in itself will be another set of videos. Okay, so we'll be going into detail of what all things are there into like move semantics and copy semantics. Okay, so these are the very crucial parts. It's just that I'm trying to set the stage for like how exactly memory management is done in CPP and how we can do things efficiently. Okay, so this is just a first step or the initial stages where we are getting a crux of the topic. So that is why I'm not writing much of the code. I'm just trying to give you very bare bones examples of how things are working over here. So in the upcoming videos we'll go into much more details of how every mechanism works. Okay, for now just assume things. Okay, so you might have some wrong assumptions. I might be explaining some slightly what you call nuanced things into like boiled down versions. Okay, so let's not worry about it for now. Okay, so here also in the move, this thing move constructor, move assignment, so there you see here also the data is deleted. Okay, the only difference that you find is after copy you never assign the original thing to anything else. Okay, here you assigned it to a null pointer. Okay, the one that was being copied, okay, from the original source. You do not what you call destroy the source. In move, what you do is you are essentially swapping the pointers in itself. So here the original thing will be null now. Okay, nullify the original pointer, and that's it. And here we have written here we have created object 1. Object 2 is like deep copied. Like previously we had done a shallow copy, so this is how deep copy works here. So like here at the implementation level only you can change these things. Okay, so how you are writing at the like actual assignment, there's no difference as such in the assignment, but in the internal code how you like scaffold these things is where it makes the difference. And here if you use the std move, okay, so this is a critical difference over here. So like copy, you don't have to write anything over here, but for move constructor or this move thing you need to use the std move. Okay, so how std move works and all those nuances we'll see in some other video, but for now just remember to move something you need to use std move. Okay, and here again we have used copy assignment with a deep copy, and here we have just written a simple test, so we'll just test it again. So perfect area. Okay, so here you can see total of 3 resources were there: object 1, object 2, object 3, and 3 resources were released finally. Okay, so resource was initially acquired. Okay, object was created. Okay, resource acquired, then copy constructed with a deep copy, move constructed here. Like see the sequence of operation, third operation is the move constructed, and again there is copy assigned with a deep copy. Okay, object 3 to object 2 we have copied, and finally all 3 resources are released. Okay, so this is just how you could say the basic premise of how RAII works, like resource acquisition is initialization, that idiom works. Okay, so we'll get into further details in the upcoming videos. Okay, so we'll see how constructors are to be constructed properly. Okay, so we'll take some real examples of like using real resources like file handles and stuff, and we'll see how things can be explored. Okay, see you next time. Thank you.